Okay, guys, welcome to our next webinar, which is Observability on Kubernetes with Elastic Stack by Chidambaram. And a big thanks to Chidam for quickly agreeing to do this webinar in a short notice. So we actually had an webinar planned in the morning, and that speaker wasn't able to join. And Chidam was very quick to say yes, and he agreed to join. Right. So you might find some slides. Maybe he may not be fully ready, but I am sure. I mean, the topic that he's going to present is going to be very useful for us. And let me introduce our speaker. Our speaker of the day is Chidambaram. He's working with Elastic. He has over 19 years of IT experience, and he has worked with many companies in the past, like Sun Microsystem, Telecom, Fujitsu, as well as Red Hat. Right now, he's working as a senior, as a principal solutions architect at Elastic, and he's been helping a lot of enterprise customers with their needs. And let me open this floor to Chidambaram, and let's begin, right? And Chidam, it's up to you now. The floor is yours.
Thank you so much, Ranjit. I hope I'm audible and clear. So good evening, everyone, and nice to meet you, everyone, virtually here. So my name is Chidam. As Ranjit introduced, I'm a principal solution architect based in Elastic, Singapore. All right. So today, for next maybe 50 minutes, I'll just walk through observability on Kubernetes with Elastic Stack and how it can help developers, operations teams, SREs, or administrators. Having an end-to-end observability gives you a full control of complete insights into your infrastructure, into your applications. So, and also the challenges that you will face if you don't have that visibility, and those things I will share. And I believe most of them are familiar with Kubernetes. So I will give a little introduction about Elastic Stack and the insights, the internals of Elastic Stack, how it works, what is Elastic Stack is. I'll go with that introduction. So this is the agenda which I'm going to talk about, the architecture, the introduction, how you ingest the data. So when you talk about ingest data, it's about all the key logs, metrics, application traces, how you ingest those things into Elastic Stack, and how you can visualize using Elastic Stack for your end-to-end observability, and some of the use cases and North Star features of Elastic. All right. You can make it interactive because I believe is a quite a community group here, and you have taken your weekend evening off to listen to this. That you must be take away the learnings from this session, right? So just feel free to interact, and if you want to ask any questions, we can have a last few minutes of Q&A sessions to clarify those things. So I'll try my best to explain the concepts and make you understand and make this session worthwhile for the community here. All right. I'll just go with, in terms of Elastic, so it was founded in 2012. So it is commonly called as ELK stack. So what is ELK is Elastic Logstash Kibana. And so almost about 2,800 plus employees globally. And Elastic started as an open source community software, and almost like 4 billion plus downloads has happened. And 54% of Fortune 500 companies are using Elastic and trust Elastic. So if just to give a very quick comparison or analogy for you to understand, if you don't know Elastic, everyone is using Elastic in our day-to-day life. So for example, you might be seeing a search functionality in your e-commerce websites. Like, in India, Meesho is one of the biggest, second largest e-commerce websites. So similarly, a lot of different e-commerce websites where you go and search, and you need to get your searched items or products faster. So the backend, the search function is powered by Elasticsearch. right? Similarly, kind of like Grab. So here we use it for in Singapore for taxi booking. So taxi, so the backend search with the geospatial capabilities, all those things is being powered by Elasticsearch, right? And to compare with another analogy like movies, like Netflix, everyone is fond of movies, and you do watch Netflix. So you want to know, get your favorite movies, and it has to provide you the suggestions, recommendations based on your user behavior, based on your history, and all those things, right? So those things back in the search is powered by Elastic, and that's how we started with Elastic. It bound with the core functionality of Elasticsearch, and then later the ELK stack is formed as a Elastic Logstash Kibana. So just keep it simple, like Elastic is where it stores all the data in a Elastic common schema, and Logstash is kind of like a log parsing, log enrichment, or data enrichments, and Kibana is where you visualize, right? And so over the years, there was a lot of innovation went into Elastic Stack, and after the addition of pre-alert, it's a machine learning platform. So Elasticsearch has become intelligent in having a machine learning, both supervised and unsupervised ML. And with the unsupervised machine learning, so it do has the automated anomaly detections, time series forecasting for storing all the data, and Kibana lens is introduced to visualize. It's a powerful visualization within Kibana, and Elasticsearch also acquired a company called Endgame. So when we talk about Stack, right? So I will explain on the stack, but just to give a very high level on the roadmap. So it started with search, then the observability capability and core functions has gone in. So it used for observability, and after the end game, so it's a security solution. So where Elastic Stack is being used for SIEM and endpoint security as well. So in a single stack where you can able to perform all the three use cases, search, observability, and security in a single stack with the data, which is what are you already ingested into it, right? So that kind of like gives you a complete visibility of data which is ingesting into the Elastic Stack. And there are different innovations happen, like so Elasticsearch is on cloud. So you, even as a community, you can just go, if you want to trial, you can just go cloud.elastic.co and just provision Elastic cluster, a free 15 days free trial use for you to play around. And if you want to download the community version, the free and basic versions, you can also download and play around, right? And so there are a lot of innovations happen. And the latest current trend, the most happening thing is using vector search. Elastic has an inbuilt vector search capabilities. So the data stores as a vectors and used for search functionalities for different vectors. And that is being used with the use cases like LLM and Gen AI use cases. And so the generative AI is something which is currently kind of like everyone is talking about it. And Elasticsearch has been involved in this vector search for a couple of years and so many years back. And so we already productionized that particular kind of like a vector search and AI assistant in observability, in search, and in security. So it's a quick the roadmap on the Elasticsearch, right? And if you look at the Elasticsearch, where you can ingest all kinds of data. You can ingest unstructured data, semi-structured data, and structured data. So it can be from your websites, from your file system, application, logs, metrics, events. And if you take Kubernetes platform as a, for example, so Kubernetes platform is kind of like a container orchestrator where your microservices applications are onboarded, and where it's a very complex kind of like a architecture where you need to trace all the different microservices applications and link together as a single applications where you wanted to visualize, right? And at the same time, you want to know what is happening in your Kubernetes platform, what is happening in your underlying pods, containers, the logs, metrics that's been generated from every single pods. And quickly, you should be able to investigate and isolate the problem and get into the root cause, right? And also to have the complete health of the entire Kubernetes platforms. Right? And and the outcome will be definitely increasing user expectations, digital transformations, and cloud migrations. So this is how the stack grows. Like the Elastic Stack, you can deploy anywhere your data resides. So you can deploy in a public cloud, you can deploy in a hybrid cloud, you can deploy in on-premises. So there is no restrictions to it. And even you can deploy Elastic Stack on your Kubernetes cluster, right? And so we do have Elastic Stack. We do have a Kubernetes operator. So we call it as ECK, Elastic Stack, Elastic Cloud for Kubernetes. So it's an ECK operator, so which does has official and certified images on catalog in Red Hat catalogs in Docker and all the official places where you can download the operators and get it installed. So uh, so you need to have the data ingestions from your source. So for example, in this case, assume that your application which is running on your Kubernetes is the source, and you need to ingest all kind of data like your logs. These logs is very much important for even for developers, for operations, for administrators, every kind of people. Logs is important. They want to know what is happening exact when there is an error or when there is a change happen. Metrics is something which gives you the insights of your CPU memory and resources consumptions and all those things. What is happening disk storage. Application. So when we talk about applications which is running in a monolithic and as well as which is running on a microservices, so you need to know what is the application performing and the application traces. So how long complete a transaction takes and where are the points it travels, and what is the to give the complete visibility of the complete application performance metrics. And so that's the stack which I'm talking about, right? And obviously, when we talk about, we just don't talk about Kubernetes. We talk about the wider area of like a data centers, where you also want to know what is happening in your network, what is happening in your security, what is happening in your storage in that point in time. So most of the time, what is happening is people are having a different proprietary observability or monitoring tools, I would say. The monitoring tools will show it perform very well for that particular their own softwares or their own applications or their own monitoring like a network and all those things, right? And but I will not have a complete visibility what is happening in my network when my application is slow. What is happening in my in my underlying VMs, which is running, which is hosting my containers when there is a error happen, right? So all those things, how do I correlate? So that is very much important that I need to correlate in that point in time to see what is happening exactly in this point in time in each and every areas, right? So that's a correlation engine which comes out of the box with Elasticsearch. So now what I'm doing is I need to ingest all the data. So when I ingest all the data so I ingest everything. So I'll talk about what the different ingestion methods, but the ingestion is the first thing, right? So when I ingest, everything stores into the Elastic Stack where I can search and do the analysis, right? And so all the data becomes searchable. All the data is written in an Elastic Common schema in a structured manner, right? So all these things is taken care by Elastic Stack. And once I have the data searchable, once I have the data which I can do the analysis, I can then visualize and explore my data in a different form, right? And I can even do a near real time kind of like a visualizations of my data coming in, and I can able to build a beautiful dashboards for the complete observability of what I wanted to view. So this is the three layers which I was talking about. The ingest, everything is kind of like the log ingestions. So where I ingest metrics, logs, traces. So there is a different way to ingest. Like you can also standardize the ingestion method using OpenTelemetry. So OTel is fully supported with Elasticstack for data ingestions. And in fact, Elastic has contributed our ECS, we call it as Elastic Common Schema, to OTel. So that means OTel now follows Elastic Common Schema, so which becomes 100% supported and native when you are going with OTel for data ingestions into Elasticstack. And also we ingest data from eBPF. What is eBPF is, if you are a Linux experts, so you would know the kernel. And so many a times we may missed out what is happening in the kernel side. So eBPF is something which ingest the data from the kernel into Elasticstack. And I can able to visualize the complete data, the kernel data, as a universal profiler in my Elasticstack, and that can give you insights. For example, take a developer. If let's say if I written a code, I can able to tell how long each piece of code take consume, how much CPU or memory consume on the systems. I can optimize my code. I can improve my code quality with this data, right? And it is and for all the cloud native applications. And the search analysis where it has a out of the box and out of the box elastic search, and it does has machine learning, and it also has a AIOps capability for like a spike rates analysis, and a different kind of like a AIOps capability. And also the visualizations is where we do in Kibana. So these are the three use cases which I was talking about: enterprise search, observability, and security. So today for the sessions, I will talk about observability, which is our key topic, right? But customer or even community people, you do not need to have a different cluster for different use cases, right? Let's say if I'm building something for a search, I want to do a knowledge-based search systems for my own use, right? So I can just go and build on the same Elasticstack, which has enterprise search capability, and I don't need to set up a separate system or cluster for it. Similarly, observability and similarly security, all three in the same stack. So this forms complete the Elasticsearch platform. So Kibana is where you explore, visualize, and engage Elasticsearch and integration. So it comes with a lot of out-of-the-box integrations for you to connect and collect and alerts. So you can also integrate with your ITSM systems like ServiceNow or kind of like Genius and all those things. If you want to send the alerts and create a ticket, so Elasticstack has out-of-the-box integrations. And I can also ingest data from public clouds like AWS, like CloudWatch. So it has out-of-the-box connectors where I can just use the connectors to collect those data and ingest into the. So there are a lot of out-of-the-box integrations available. So architecture. So when I'm ingesting the data, right? So the data has been, let's say if it is a document, is written in a JSON format. And so the architecture, we have a different architecture, like all the data goes and sits in a node, which can be your Elasticsearch VMs. So we make a role as a data node, right? So the data node is where your data sits, right? And the data is written as an index. And so when I say replica 2, that means, I mean, when I say I want to have a replica, that means it will write as a shards, and it creates a replica into multiple shards, and it will store in like a primary and replica into different. So this is more of like a high availability within the clusters, right? And there are some so this stack, if you look at, so there are different node roles. So we have like a coordinator nodes, we have ingest data nodes, we have a master data and machine learning and different node roles here, right? So master is where it manages the health of your cluster, right? So typically you can just go with one master or three masters for high availability. And there are you can have you can scale data nodes, a number of data nodes, and you will have ingest nodes if you want to have a specific nodes to handle the data ingestions. If you're not specifying a coordinator, or if you're not specifying as ingest nodes, all the data node performs the role of coordinators, right? And ingest nodes. And machine learning nodes, if let's say if you want to perform a machine learning task, like then you may need separate nodes to be assigned as a machine learning nodes. So where it does all the unsupervised and supervised machine learning. So because it's a highly compute intensive when it comes to machine learning. And so the data nodes, when it comes into the data, then it's like it stores as an index and shards and replicas, and each index and shards will store as a multiple segments. So this is the overall Elastic cluster node types. So master, data nodes, ingest nodes, for ingest pipelines to transform and enrich before indexing. So if let's say if I'm ingesting a data logs and I want to improve enrich my logs data, adding additional fields which I need, I can do all those enrichment transformations, all those things by writing ingest pipelines, right? And then transform nodes is for data transformations, and machine learning is to run machine learning jobs here, right? There are different, you might see data hot, data warm, different node types, and there is also data frozen and data cold. So those are all different index lifecycle management. So where I can optimize my storage cost by having a data retention on each nodes. So I can put a high performing storage on data hot, and I can store it for 2 days. And after 2 days, the data has to move, the index has to move from hot tier to warm tier. And warm tier, you can have a HDD. And after that, I wanted to move to a frozen tier where I have the object storage. And the frozen tier is where you can store a searchable snapshot you can store as a searchable snapshot in your frozen tier as object storage. So it performs even faster. It's just the name is frozen tiers, and it can able to retrieve the data from your frozen tier faster. So this is how the index operation, the data processing flow looks like. So when I put a data, it goes into the ingest pipelines. If there's any ingest pipeline, it goes into the ingest nodes. And then after the data passing, it goes to the route and goes to the data nodes. And so how the data is being replica. So it losing shard and losing replica, and it stores into the segment, and then it will be like on the nodes, you will see like a file systems, like a wireless Elasticsearch data. So that's how it stores in the Elasticsearch, is the underlying things. So if you look at the network compute, all those things is like each node rules, what is it, whether it is a network intensive or compute intensive or storage intensive. So that's the type here. So all the data is being mapped so like when I write a data into the Elastic Stack, right? So the easiest schema, so it has the names of the fields, the data types of the fields, and how the fields should be indexed and stored by the Lucian and all those things. So that's the mapping. So there's a different types of mapping to the data fields. It's like a static mapping and dynamic mapping. So most of the time people use the dynamic mapping, that's automatically it maps and things into the fields for the data mapping. And for example, let's say if I'm posting my blocks underscore blog, so the username skimchi comment is this and created at and timestamps and all those things. So this you see the mapping of the fields, and if there is a field which is not already defined in a mapping, then that can be added as a enrichment into the mapping. So this is the data tiering, which I talk about. So probably I'll just move on because this is something which goes into cost optimizations when it comes to the data tier, how the blocks has been ingested. So I wanted to quickly touch on the concepts on Kubernetes, how the data is being configured and ingested here. So, but this is just a very high level. I would just wanted to flash it, the different data usage and performance. So you see here the frozen tier, even though it is called frozen tier, but you can query the data within 10 seconds or within seconds or minutes. The performance is that fast. And this is a shard distribution, so where it distributes between hot and warm tiers. So that you can even store primary shards in a hot tier and a replica shard in a warm tier in order to have the things storage optimized. And shard distribution in the cold tier, where I can have a hot tier primary shards in the high performing disk hot nodes, and I can also put a replica shard in a snapshot in the object storage. And frozen tier is similarly like I put everything in the object storage. And I do have a buffer, kind of like a cache disk, so which use it for frequent read-write operations before it sends to the frozen tier. And this is the cost versus density. So hot tier, I will need like kind of like a 1:30 ratio. So it's like 1 GB of memory. is required to process 30 GB of data. So that's the hot tier kind of like a ratio, and warm tier is like 1 GB of memory to process 160 GB of data. And similarly, cold tier is 1 GB of memory to process 320 GB of data, which is 10 times of hot. And the frozen tier is 1 GB of memory to process 1600 GB of data. Okay, that's on the life cycle. So these things you can configure, these policies you can configure on Elasticstack itself. So hot phase, warm phase, cold phase. And so you can have petabytes of data into it. Okay, so now comes into the complete workflow, right? So imagine that I have my infrastructures. So infrastructures where it can be your physical servers, it can be your virtual machines, it can be your container platforms, Kubernetes. And so I will have the operating systems running on those systems and network storage. So uh, and you can have different types of infrastructures, like even applications. You can have microservices and monolithic applications that can be middleware, and businesses, different application business and everything. So this is the first point. First thing first, I wanted to ingest the data from all these stacks, right? So, and what data I need from these stacks is like, from the infra, I will need like metrics and logs. And from application, I will need APM metrics and traces, and businesses probably transaction data, right? And how I ingest these data, so is where it comes into like, so we call it the concept called beats. So beats is the data ingestion. So there is a different beats available, like file beats, which ingest all the logs or files, metric beats, which ingest all the metrics data, heartbeat, which ingest the heartbeat data. So there's a different beats, and Elastic is also introduced Elastic Agent, so which is nothing but, and backend is still using the file beats and other things. So you can install one agent to, instead of having multiple beats configured, you can have a single agent which can ingest both your logs and metrics together, right? So that's how the Elastic Agent is. And so applications, so that we do also have the Elastic Agent, APM, Elastic APM agents, so which ingest your APM metrics and traces. So the traces is very important here, because trace, which ingest along with the trace ID. So the Elastic APM agent takes care of it to ingest the trace ID along with the APM metrics. And that kind of like have, you can able to see the complete APM service map of the complete applications. I'll show you how it looks like. And or if you want to standardize on a standard ingestions, you can go with hotel agent. So Elastic APM agent also natively has the hotel protocol supported within it, right? And so these are the data required, and this is how you ingest the data into Elasticstack. And this data ingest into Elasticstack. So I explained the concept of what is happening within the Elasticstack so far. And you can also ingest other data from your CMDB or API gateway or identity managements. And you can able to visualize the complete end-to-end service availability of all this data in a single place. So that's a most powerful statement, right? You can see a complete correlation of the data in a single place of all these, which you see on the left-hand side. That's completely your end-to-end infrastructures. And like I mentioned, so it has the out-of-the-box connectors. So I can correlate all the alerts. I can send it to ITSM to create the tickets, and I can also create those service level indicators or service level objectives based burn down rates alerts based on the data that is being ingested. And I can also able to kind of like ingest, do the machine learning and do a perform anomaly detections. So if there is any kind of like anomalies, if let's say if naturally if my application is generating 1,000 logs, right, and suddenly my logs rates spikes, suddenly I see 50,000 logs on my applications. That means something is not right, right? Either it could be a known change, or it could be something somebody is ingesting or running something in the systems unauthorized. So that is how the pattern changes, right? So this pattern is being auto-learned by the machine learning. So that's what we call it as unsupervised machine learning. And so if there is something which is a spike up or spike down, so it generates an anomaly, and that anomaly can be triggered as alerts and sent to your infrastructures. And on the right hand side, you can use it to, I mean, you can use it kind of like enrich with the AI assistant for you to see what is the problem, what is this log message is about. So that kind of is more of like a open AI integrations. And because when it comes to chat GPT kind of things, the data, whatever you are going to put in ChatGPT is going to be in around the world, right? So, but how do you maintain your private data being private? So that is where Elastic acts as a bridge between your private data and the Gen AI LLMs, right? And it masks your private informations, and then it uses the connectors to just to use for the generative of text, and it just takes the context from your data because your Elasticsearch has all your data, which has all the complete context. So that's how it is ingesting here. And yeah, so obviously, if you want to bring down like a mean time to resolve MTTR or MTTK and all those things, you can automate with the automations that you wanted to do it, and which can go and resolve, because once you know what is the problem is, it's easy to recover, right, and remediate. So, and that's how you can. And in Kibana is also is part of Elasticstack, and so you can able to completely visualize your data ingestions. You can search your data faster, and you can discover, and you can build your own dashboards and analyzing all those things. You can able to do it on the Kibana itself, right? So there's a different methods that you can able to build. You can discover your data. So whatever that logs or the data being ingested, you can able to discover in a single place. And with the lens, you can able to build multiple visualizations, graphs, and all those things. And you can also, Elastic has the geospatial. You can also map it to maps to see your global data centers and all those things, and the positions. And you can also have your machine learning anomaly detections across all the applications in a single places, right? I'll just go on to the use cases because I know we are 7:37. I mean, we have 20 minutes left. So let me just go into this. So the observability, so where the key features is like you can do log analytics, you can do APM, infrastructure monitoring, synthetic monitoring. You can also do a real user monitoring plus mobile monitoring, and you can also do a continuous profiling here, right? And I'll just go in. So when it comes to the log monitoring, so probably I think it is easy to explain using demo here. So you look at here. So this is my dashboard. So I'll just go into the dashboards. So this is my dashboard where I have all my observability and security analytics different ways, and this is my Kibana. And if I look at my Kibana, so where I have analytics, so where I can do a discover, build a dashboard, and machine learning, and observability where I can do overview alerts, SLO logs, infrastructure, APM, and all those things. So I'll start with discover, because when my data is ingested into Elasticstack, so discover is the place where I see the complete data that has been ingested in a proper field, right? So you see here it's kind of like a messy, it's a lot of data is being here, right? So let's say if I want to just search only for the host names, right? So I just wanted to search for the host. I want to search for, let's say, host name. So I want host name to be in the field, and I want the host IP, and I want my host uptime, and I want my, let's say, messages. I want my logs messages, right? I can take any messages. So I'll just take, probably I just wanted to have this active message. It's not there. Okay.
Yeah. Hey, Chidam, can you just make it a little bit bigger? I mean, the font size, something.
Sure. How is it now? Is it better?
Yeah, it's better. It's better. It's better.
Okay. So I can able to filter all those things. If you look at here, right, within a fraction of seconds, it has really went and searched the complete like 677,000 of hits of lock lines, and I can able to filter the way I want it, right? And I can also do kind of like a sort out from high to low, low to high. I can also fit into the systems and I can go back to see what has happened in last 1 hour, the data, right? So all those data I can able to search. I can able to search that flexible I have, right? I can also write a query. So I can write a Kibana query language to find out I want the host agent.host, yeah, host.containerized equals true. So I mean, I can just search whatever that I want. Yeah, I can just search whatever I want, and I can able to run the query from here. It's a quite powerful language, query language, which I can do it. And the data sets, I can search in metrics, I can search in logs. So there's a different data sets, which is in whichever that data has been ingested, and I can able to find out from all those things. So this is the discover where I see all the data has been coming in. And let me go into, so let's say if I wanted to see the complete dashboard which has been built. So you see here, I have built a complete dashboard where I can able to see the complete geospatial worldwide and the load, the front-end response time of my applications, the logs, the log level and outages informations, metrics. So this is the machine learning which of my different application services, CPU usage by pods, my containers, all the pods. So all these are microservices. So I'm running kind of like a hipster shopping website, and all these are different microservices which is running on the Kubernetes, and I can able to see the complete CPU usage by pod, and I can even drill down to that particular pod, and at the same time I can able to see when there is a memory usage, what is my pod. I can able to see the correlations here, and uptimes of my different services, and APM of my application, the number of requests, if there is any APM request to the data store, if there is any failures, and all the anomaly detections, everything I can able to do it. And I can also, let's say I wanted to see the card services, I can just zoom down into that particular card services, why there is a spike up. And I can also go into the particular time zones. If there is any anomaly, I can just go in and see, apply that particular time filter to see what is the anomaly in that point in time. And it takes me to that exact anomaly by which application. So the anomaly is by the product catalog service and all those things. So these are the different dashboards that you can use as a drill down deep dive dashboards, and you can also build multiple dashboards with here, right? And I'll just go into the observability overview. So this is my overview. So where I can see different alerts, hosts, services, monitors, everything. So obviously, whatever you do, you can apply the time frame for the different timestamps that you wanted to see. And the alerts, you can configure different alert rules to see if there is any alerts that's been triggered. And these alerts can be sent to your ITSM or elsewhere, or even you can also send it to the case, which is out of the box case in this particular observability, where you can create a case and assign to the task. SLO, service level objectives, which you can create, and log streams. So it's where you ingest all the data ingestions, the logs comes here. And so this is one of the Gen AI feature, which probably I can just show you. Let's say if there is something which I wanted to understand what it is, then I can just go and look into this and view in details. And so this is the Gen AI, but this particular Gen AI is not available in open source. Let me just call it out. So this is available in the subscription, and it has a connector to the Azure OpenAI. So let's say if I wanted to see what is this messages about, if I'm new to observability team and I don't know what is the application messages about, I just need to go and ask, and it will generate the text in a human understandable language, and it tells me what is this message is about. And if I want to know the similar messages I want to find in a query language, I can just ask, how do I find similar log messages? So it provides me the Kibana query language, which I just need to copy, and I just need to paste it in the query language window, which just now I show it in the dashboards, and I can able to get all the similar messages. Or if I want to know more, I can start using the chat to find out more information. So all this data is reside internally as a private data, right? And this is the anomalies which is been detected across all the different anomalies application services. I can also do the log categorization. So all these things is under logs, right? So log categorization is quite powerful, where let's say if there is any particular is a failure in login, and I wanted to categorize all those things in a different message count, right, from different payment services. So all these are from different application logs, which is ingested into Elasticstack, but it can correlate and it tells me the exact all the different data sets in a single place. And I can able to see the complete log count, and I can categorize the logs, which is the high logs. So what is happening into that particular product, and I can straight away zoom in to that particular log messages, what is happening here. Similarly, when it comes to infrastructures, so I can check on my inventory. Let's say this is running on the Google Kubernetes GKE, where I can able to see the complete metrics of the GKE platform, which is running underneath the CPU load, memory, network, all those things, and logs. I can integrate with the logs process. So this is is a process that is running in the systems, right? Like PS minus EF, you can see all the process that is running inside, and you can able to correlate all these things in a single places. So that is that's the beauty here, right? So I'm not going to multiple systems, logging in to see what is the happening each and every places. Similarly, I can go and look into the Kubernetes pods, and I can able to see what is my pod logs, my pod metrics, APM traces, and pod and uptime. And I can see the Docker containers, or if it is a cloud native, I can also see a different cloud native, all the CPU usage, memory usage, traffic, all those things I can able to see for different timestamps, and even I can able to see it in near real time as well. And also I can have a metric explorer where I can able to explore the cardinality of different metrics, which has been ingested into the Elasticstack. And I can able to set the search filter, query, and all those things for different metrics. And host UI for me to see the complete insights into the particular host. I wanted to see what is happening in this host, including the CPU usage, including the disk space usage, disk write, IOPS, all those things I can able to go with the timestamps series, and I can able to correlate what when my disk IOPS is high, whether is my disk write IOPS is low or high. I can able to see. So I mean, disk throughput. I can compare all those things with the different metrics here, right? And similarly, when it comes to the APM, so where I can able to, so once I instrument all the application into the Elasticstack, I can able to see those application services here, and it builds a service map. So if you look at here from front end to the back end, including the PostgreSQL, it gives the complete service map for me. And if there's any anomaly is being detected and all those things I can able to see. And if I wanted to find out a service map, if there's any anomaly, I can able to straight away go in and look into it. So let me just generate one anomaly here so that you can see how it looks like. Okay, so yeah, I generate one anomaly here, and so you can see the color change for the advert service. So I click here, so there's a anomaly 99, and I can able to see immediately what is the latency or failed transactions for these applications and all those things. And I can straight away go into the service details. It takes me to the services. I can compare whether it is day before or week before or expected bounce, and I can able to see the complete latency. And these are the different anomalies which triggered. I can able to see the transactions, failed transactions. So there is a failed transaction happen at 6 p.m. and I can see what is the contributing factor for the failed transactions. And I can straight away click on to the error messages. It takes me to the error message, error occurrence, and I can able to see the root cause in a couple of minutes, or less than few minutes. And again, the AI assistant which I was talking about, you can also use it here to see what is the culprit, and it also provides how you can resolve a particular issue or error message. It gives you the root cause of this issue could be, and what you can do to overcome this. Again, I just wanted to call out this AI assistant is not available in open source, but it's a good features to have, which enterprise organizations are looking at, right? And you can just start looking into this. And traces, where I can able to see the complete traces. Even here, if I look into the service map, right, when I go into this particular service details, I can able to do the latency correlations. So I can just go into this one particular transactions. I can see the complete latency of that particular transactions, and I can have the latency distributions, and I can see the full trace of that particular application, how long the application latency has taken, and I can also do the complete. So this is the complete time taken for each and every traces that for this particular transaction happen. And I can also do the I can investigate if I want to investigate using the trace loss, or I can go to the transaction in the discover, which I showed you earlier. And I can also do the latency correlations to see correlate and see what is the cause of that particular latency compared to yesterday and day before yesterday or today. Right, all those things correlations I can able to do it, and it'll give me the complete correlation view. So this is the traces which I can explore, and dependencies. This is the synthetic monitoring. So it has the out-of-the-box synthetic monitoring where I can able to monitor the applications which is running on anywhere from outside in, right? So I can monitor the, let's say I just wanted to give the URL, and I can monitor the application how it is performing from a user from a Japan or from a user from Hong Kong. And I can also go to the details into the complete monitor to see whether the page has been loaded for him. So it takes the snapshot of each runs, whether the application pages has been run, and what is the alerts or latency and all those things. So I can go to that level of details here to see each and every transaction and monitoring details here. So that's a synthetic monitoring. And I can also do the uptime monitors to see my system is up, every endpoint is working fine, if there's any TLS certificate which is expiring, if I expire, send me alerts, and so on. And so those things are under the uptime monitor and TLS certificates. So this is the user experience, which is a real user monitoring, REM. So this is the collects all the core web vitals from your applications that is running on anywhere in your Kubernetes or anywhere in the systems, and it can able to see how long a user spent and what is the user behavior. All those core web vitals it can able to capture, and you can able to see whether the breakdown from the iOS or Mac OS or the operating systems or the end user. So all the real user monitoring stuffs here you can able to see it. And this is the universal profiling. So this is very much interesting for the DevOps and the developers, right? So where I can able to see the complete. Let me see if I have the stack traces configured here. I think looks like I don't have this. Okay, looks like I don't have this here. I can show you in a snapshot if I have later. Yeah. So yeah, so this one actually the frame graph tells me. Let me just see this one more time. Yeah, now I'm not going to explore now. So yeah, so this is the complete Kibana dashboard which you are seeing here, and obviously from the dev tools, because Elastic is everything is like an API. From the dev tools, I can able to execute any query like index. I can do any kind of like a query, like you can just do a search variable, so it gives you the output of the complete variable and all those things here. So it also has a profiler, grok debugger, and all those things. So this is all about the Elastic Stack which I was talking about, right? Let me just quickly cover one small thing. So when we talk about so ECK operator, so these are the different application stack that you can have. So all those things you can able to monitor using the ECK operator. So ECK is Elastic Cloud on Kubernetes. So if you want to try yourself, you can start with the Minikube, and you can just download the CRDLs and operators from. You can install the Elastic Cloud on Kubernetes operator, which will have all these things, and you can. Sorry about it. Yeah, you can. Then you can create. Elastic Stack on Kubernetes itself. And once you deploy the Elastic cluster on Kubernetes, if you're using OpenShift, the operator is already there. You just need to go and do a few clicks where you will get the ECK operator deployed. And you can forward the ports, and you can you'll get the Elastic dashboard once you deployed. And after that, if you want to monitor all the different logs, metrics, events, alerts, tracing, you can configure Elastic Stack straight away inside. I'll show you how you can ingest. Let me just go into the. So this is the ECS, the Elastic Common Schema difference, right? So when you're seeing uh, raw logs, you will see all kind of things. Whereas when it makes into a structured way, like a common schema, like source IP is a field name, and it'll give the IP address. So when you search, it can able to search faster, right? And yeah, so this is the logging in Kubernetes. So when it comes to the Kubernetes, so if you look at here, so this is the control node. So where you have the logging operator running here, and you have your Elasticsearch application running here. So each and every worker nodes where you'll have the file bit installed as a daemon set, and so the mount points has been mounted, and so the file bit reads the logs and then writes into the Elasticsearch nodes. So that's how it reads and writes. So there's a log rotation by default in Kubernetes. So generally what we do is, so we when in file bit, we add the log star wildcard, so that when the file is reading, if the log rotated and changed different file name, the file bit follows the inodes. So that's why you need to have the wildcard set up here. And yeah, and so this on the log rotations and logging, cluster level logging, and application level logging. It reads from the application containers. And what else? Yeah, it runs as a daemon set file bit. If it's Elastic Agent, you can run it as an operator. And there are a lot of events and fields Elastic Common Schema can map, right? And this is a metadata example looks like. I think I'm almost top of the hour. Probably I'll just pause here and open if there is any questions. Okay. Yep.
Hey team, if you have any questions, you can ask him. But I do have a question for Chidam. Is that it could be good if you can share those steps that you shared in the slide, right? How to get the ECS operator on the PiniQ, or maybe that slides. I don't know, whichever is comfortable for you.
I will share I mean, for ECK, right? I'll share the ECK installations GitHub page, Elastic. So there's a GitHub page where it tells you very much clearly, right? Is the Elastic Cloud and Kubernetes. So it is an open source where you can able to see the complete quick start, how you can deploy, how you can set up the local development pages and all those things. So all those information is here. So I can share this with you, Rajana. Yeah.
Yeah, maybe you could just paste it in the chat, maybe later, not now. Yeah. Any questions, team, for Chidam? I know. I mean,
Yes,
it
you
was like, it was too, what do you call it? It was too interesting, and there was a lot of new things for us. So maybe people are just trying to digest it. Um, so
I'm
just one
sorry.
more question. Yeah. So one more question. So about the APM agents, right? So you were
Yeah.
talking about API agents. So
Mm.
does it support for all coding language? Let's say, for example, like PHP, Java. So does it have the APM agents for all these coding
Yeah.
languages or for the applications?
Yeah. So so if you look at so there's this page. I mean, if you look at the integration side, so let's say if I wanted to integrate with APM, and you can see all the different language, Java, um, Node.js, PHP, .NET, OpenTelemetry. So you just need to instrument by adding a small piece of code. And that's it. You don't need to change your source code. You don't need to edit anything. You just need to add pointing your logs from your application to send to the Elastic endpoints.
Oh, okay. Okay.
Yeah. And you can see all those integrations here, Elastic integrations, APM. Um, so there's a APM integration. So you can see different integrations that's been, yeah. I can share this link as well.
Okay.
There are a lot of integrations here. Yeah, I'll share it in the chat.
Okay.
Yeah. So once you, integrate using the Elastic APM agent, so you can able to see the complete APM um, service map for all your applications. So once you do it, so it'll be you can see all the APM applications, which is instrument and coming here, and where you can be able to see the complete performance metrics of your application services, and you can able to trace the application, and you can see the metrics, logs, and latency and everything, and you can correlate. So that's the beauty of it.
Okay. Thank you.
Maybe for developers, I can just show you a small quick one. If I let me see if I have the here observability log. I don't have here. But all right, yeah, you can just post questions to me while I'm just looking at. Any other questions here?
Yeah, none so far. I'm just waiting. And
Sure. Okay, I think it's in the machine learning. Yeah, probably I'll just show one more link here. So this is the Elastic Stack, futures, right? So you can see most of them under this free and open basic is all open source. So just feel free to download and play around. So there are a lot of most of the stuffs are covered under the open source. Only thing is those machine learning and the AI features, which is all covered under the enterprise. Under the subscription. If not, you can just play around with most of the open source. Yeah. So I'll just put this link as well. All right.
okay, in one of the slides, you were talking about file beat, right?
Yes.
So which is, I mean, I just since I use a Fluentd
Yeah.
a lot. So what's the difference between the Fluentd and file beat?
Okay. So Fluentd and Filebit, if you look at both are log shippers, right? So Kubernetes, by default, you can also package with Fluentd. So Fluentd is equivalent to Logstash here.
Okay.
Yeah, Fluentd is equivalent to Logstash, and FileBit's equivalent is FluentBit. So the reason why I say Logstash is if you want to do a filter at the source level, even before sending the logs, you want to do a filter. I want to send only the warning logs or error message logs. You cannot do that in Fluentd today. Whereas in the file bit, you can able to do the filter and you can then send the logs. So that's just one small example, but a lot of other features which you can able to use file bit for the data ingestions, right?
Yeah. So we actually have a question now on the chat. Is there a latency when ELK collects metrics from the cloud provider GKE, EKS and display to users?
No, I don't see there's any latency here. It's almost like a near real time. So you can use the out of the box connectors for collecting from GKE or EKS. And so Elastic Stack as a unique architecture where you can deploy a Elastic cluster on cloud itself, native to your GKE, and then you can use cross-cluster search to search across different places and to have a unified visibility. So your data is already ingested, so you have a near real-time data is already available in the cluster, and you can have a cross-cluster search to have a unified visualizations. So this is some of the integration which I was talking about is, so you can just go to integrations and you can see the uh, cloud integrations. Yeah, Google Cloud integrations. Yeah. So you can have all the integration. default integrations, and you can just get from Google Cloud as well.
Okay, so there's one question which has come in. So Sham says it can analyze metrics and logs.
Yeah.
So we can replace Prometheus Grafana stack with ELK, right?
Yes.
We will get log processing as an add-on.
Yeah, you can absolutely you can replace Prometheus Grafana stack with ELK, because Elastic Stack has it has everything inside. It has event time series. It has metrics. It has Kibana to visualize. So you can replace Prometheus Grafana stack with the Elastic Logstash Kibana, and it's all in. So you don't need to manage different tools and stacks. And I mean, if you already your customers having Prometheus where you wanted to ingest metrics from Prometheus to Elastic, so it is also supported. So yeah, all is like you want to ingest the data from logs, metrics, traces, whatever that you wanted to observe into Elasticstack by either of ways. Yeah.
Yeah. Any further questions, team? Okay, I guess we can close the webinar. So thanks a lot, Chidam, for helping us with much interesting session on Elastic Stack and what it can show us and how a business can gain. I know one place to view all your pod data or your metrics, your traces, everything in one place in one dashboard. So that is very interesting. And I hope our guys will go back and go through those links that you have shared, and they start to work with the ECS or the EC case or the operator to begin with. And yeah, so thank you to them a lot. I mean, this was an awesome session for me, at least. I'm sure that Sharath and Sham were all looking at ELK and trying to even replace some of those existing stack. Yeah. So okay, someone was speaking. Yeah. Okay. Yeah. So let me stop the recording and